Gray is Davidson RoboTex's newest robot, designed to complete multiple surgical procedures in the 2023 Incision Decision Challenge. We programmed Gray in Simulink, an industry-standard framework created by MathWorks, which allows us to easily visualize and develop Gray's control flow. Let's enter the cortex to see how Gray's program works. We divided Gray's functions into several subsystems to improve code organization and readability. We implemented an arcade drive system to allow Gray to maneuver around SimBody with only one joystick, so we could utilize the other joystick for camera control. We filtered the joysticks through deadbands to prevent the drive motors from accidentally activating from small inputs. A slow speed toggle button scales the drive speeds down for precision control, which is especially useful in blind tasks. Gray can also autonomously complete the brain biopsy procedure, taking input from 3 infrared sensors to follow the tracer isotope path on SimBody. We programmed the line follower logic with the Simulink state flow chart. We used an AND operator to prevent accidental autonomous activation by requiring 2 buttons to be pressed. Another button cancels autonomous mode. The state flow also outputs a signal to notify other systems of when Gray is in autonomous mode. The state flow implements a loop to determine Gray's steering depending on which of the 3 IR sensors detects the white line. The line follower also features an automatic backing system. If the brain biopsy needle misses its target, Gray will back up and try again. We used sum blocks to combine drive motor signals from the drive and autonomous systems. The vein harvester mechanism, which is used for the coronary artery bypass procedure, is raised and lowered with 2 buttons. We used the subtract and gain blocks to feed the 2 button inputs into the DC motor that manages the front vein harvester. A similar system controls Gray's lift code, which simultaneously adjusts our multi-tool height, camera height, and an additional rear vein harvester. A limit switch prevents the lift system from moving too far upwards and accidentally damaging Gray. The camera mechanism lets the driver see different parts of the robot during blind procedures. A single joystick controls the speed of the camera mount's pitch and yaw servos, and deadbands prevent it from drifting. A gamepad button can alternatively toggle the camera's positions between 3 useful angles, the multi-tool and the front and rear vein harvesters. We implemented this with another state flow chart, using the rising operator to move between states when the button is pressed. Gray's multi-tool, which can insert stents, remove plaque, and collect biopsy samples, is controlled with a simple state flow chart, which toggles the tool's angle when a button is pressed. The tool also automatically goes into position for the brain biopsy when Gray enters autonomous mode, using the signal from the line follower state flow. The waste management state flow controls a servo to hold and dispense plaque bricks and collect brain biopsy samples based on 2 buttons. When the robot begins the brain biopsy procedure, the servo also automatically retracts to prepare to collect biopsy samples. With this Simulink program, Gray will contribute to the safety and efficiency of medical technology.